Okay, another thing we should look at is page 668. There's a box there, and it talks about differentiation rules for vector functions. And I'm going to talk specifically about 5 and 7, because on the surface it appears that they may violate this idea that I've had about section 11.1 and 11.2, and that is that really when you're dealing with these vector functions, you can think about them as, when you take the derivative or integrate, as a composite of the function for x, y, and z. And when you want the derivative of a vector function, you simply take the derivative of the composite parts. So what about this number 5 here? Is this somehow breaking my rule when they say this is equal to, well, what's going on here? Equal to, let me get it right, u of prime of t, in other words, the derivative of u times vt plus ut, that vector, times the derivative of the vector, like that. Is there some magic going on here? Well, if you think about it, this is really just the product rule. And it's actually just the product rule applied to each of the x, y, and z components separately, and then just written out in vector notation. And you can convince yourself of that, but if you were to look at, you do the dot product here for the x component, let's say that we have the x component we'll call u of x of t, and the y component, the x component of v is just v sub x of t. When you take the dot product here, one of the things that's going to happen is you're going to multiply u of x of t times v of x of t. And then when you take the derivative of this with respect to time, okay, obviously that's a product rule. And you're going to wind up writing something on the form like this. Now this is obviously just done as scalar functions, right? But when you come back up here, actually I suppose I should put our x's in here to make sure that you know that they're scalar functions. When you come back here and dealing with the vectors, this is going to give you exactly the same thing. Write this out. Use the product rule. Write it out. Take the dot product. See what happens. And you will convince yourself that really the x, y, and z components are all operating independently of one another.